achieved alone. I decided to participate in this mentorship because I know I want to pursue engineering in the future, and I would like to investigate the field of aerospace engineering because it may serve as a potential career path. Since the space program has always intrigued me, I wanted to take the opportunity to learn more about it and discover exactly what makes it possible. Through the VAST program, I was able to study aerospace exploration and decide whether or not I would like to further my pursuit of the subject or follow a different career path. I believe the experience served as a useful introduction into the world of engineering that will better prepare me for the future and foreshadow what is to come. NASA's VAST program provides students with unparalleled opportunities into the world of engineering. For instance, participants have unparalleled access to labs and equipment normally unavailable for student use and gain hands-on experience with real NASA scientists and engineers while working to design a mission to Mars. While at the residential program during the summer, students are divided into 4 different groups, each with a different objective. Mission transit, getting there, human factors, living there, science and surface operations, working there, and mission integration, putting it all together. Each category possesses its own advantages, drawbacks, and unique circumstances that must eventually coalesce into a cohesive strategy for a feasible mission to the Red Planet. Because the mere thought of these applications piques profound interest in me, I knew this was the right mentorship for me, and I eagerly awaited to accomplish its associated tasks. The implications of this mentorship experience were invaluable to me. Participation in the course provided me with a better sense of the environment of engineering and what my future career will be like if I decide to pursue a career in this field. Therefore, I believe it is important to educate other students about the benefits of the program and encourage them to participate in it as well. No longer is the VAST experience an option exclusive to high school juniors, however, but there is a new program called the Virginia Space Coast Scholars that has similar objectives but is available to high school sophomores. And as I understand it, there are about 5 Ocean Lake students who are currently participating in that program right now. So if you are in this room and you are in VSCS right now, I would like to take this time to encourage you to participate in VAST because it's a wonderful experience, and if you like that, you're going to like this a lot. So educating students interested in the fields of aerospace and mechanical engineering and giving them first-hand experience into its real-world applications will hopefully interest them in pursuing a future in or related to the field, thus contributing to the scientific community and offering new perspectives and knowledge to this diverse subject. The VAST program is also vitally important because it educates participants about the United States space program through the National Aeronautics and Space Administration. The primary mission of the program is to design a mock mission to Mars, which is indeed a goal that is being designed at the current time in the actual industry. But Mars will not be the only landmark achievement with regards to space exploration, as new knowledge is pouring in every day and new advancements in technologies are being developed to enable us to explore even the furthest reaches of the galaxy in the near future. On this slide here, we have the mission integration team, which I was part of, pictured with Roger Crouch, an astronaut who came to visit us during our week at NASA Lark. He was very flamboyant, and it was really cool to see what his perspective as an astronaut to the International Space Station was. So I'm just right over there. And then down here, this was the true apogee of the entire experience because this shows the presentation of the panel of scientists and engineers, which were over there. So because we were the mission integration team, we were kind of responsible for things like logistics and budget allocation. So we were kind of like the top dogs of the 4 different teams. So we were the first to present. And since I was systems manager right there, which is the leadership role in the team, I was the one to introduce our team. And it was a bit stressful considering it was streamed live on Twitter at the time to NASA's 6 million followers. Whoever wanted to watch it could. So, here we go. This is really the process of how my mentorship changed over time as we found out more things, what would work, what wouldn't. Because there were 8 modules in total as part of the online curriculum, in addition to the final project and residential portion, it was difficult to determine how best to split up my experience into the generic 3-case study format. Initially, I had planned with Mrs. Graves to use the 5th module as my first case study, since it's so thoroughly integrated knowledge I had already learned at Ocean Lakes. This module, entitled Space Station Science, taught me about the different agencies conducting research on the International Space Station, from the Russians to the Japanese and so on. I also learned about current experiments being conducted on the ISS, especially those geared towards microgravity and life sciences, as well as the facilities and potential spin-offs that could result from such research. Excuse me. The final part of the reading section of the module divulged information about life in microgravity, meals, psychological health, and life support system. As with every other module, this one concluded with a technical report in which I was asked to design a mission by redesigning one that had already been performed by expounding upon it. And I chose to write my report on the plant Arabidopsis thaliana the Plant Academy students had the opportunity to experiment with during their sophomore year in molecular biology. The second case study was originally intended to cover my final project, in which I was required to write a report integrating information from the entire course into a manned mission architecture to Mars. This was the longest report I wrote during the online portion of BAS, and the final piece of the mentorship that would determine whether or not I would be selected to attend the summer academy at NASA LARC. The paper included my idea of what would make the most successful manned mission to Mars, and would differ from what I would do at the residential program because it included my ideas alone rather than those contributed from fellow teammates. Interestingly enough, after compiling all of the papers I had written during my time online, I found that I'd written over 100 pages. So it was really comforting to know that I was selected to participate in the summer portion, which really made it worth my time. The third and final case study would have been similar to the second, in that it revolved around designing such a mission, but I would instead reflect upon my time at NASA LARC, and thus be able to focus on the experience rather than the content of some written report. But getting back to that first case study, Mrs. Graves and I subsequently sought to publish my proposed experiment on Arabidopsis because the feedback I received from my master teacher at BAS was very positive, and she in fact commented that I should submit it directly to NASA as a legitimate possibility for a future experiment. If this were possible, I would have also included two very brief case studies as part of my oral presentation, either on another module in my residential experience, my final project in residential experience, or some similar combination. However, this route turned out to be a dead end after we realized it would not be possible to publish it because all of the information included in the paper was entirely hypothetical. So this necessitated yet another change in format. After a certain point of trying to figure out how best to deal with this issue, Mrs. Graves asked if I would be willing to be what she called a beta tester and diverge from the common format altogether. I agreed, and at that point, I set myself on the course to design a seminar presentation. So, instead of writing case studies and speaking for 15 minutes in the Schola, I would devise a lesson plan to teach a class of astronomy students, which are here today, all about the potential for manned missions to Mars. Additionally, my presentation would span 3 full blocks, and even in that extended time period, I'd have to exclude a ton of information necessary for full understanding of the subject. But the greatest emphasis would be on student interaction and their full participation in the lesson. For the seminar, I split the class into groups of 3 to work throughout each of the blocks for the various activities I had planned for them. As you can see here, these are the different groups, and you guys right in the middle right there, that's you. Okay. So here is a list of some of the various pieces of information I chose to include in my presentation, from historical Mars missions in the past, to rovers exploring the planet, to different propulsion technologies, to crew selection requirements, potential landing sites, and risk mitigation. I incorporated several techniques while I was teaching to make my presentation as interesting as possible, from embedded worksheets. This one here shows one of the worksheets I gave the students about the landing sites that were being considered for Mars missions, and I gave them the set of coordinates, and they were tasked with finding them on the map. I also included the opportunity for students to produce their own banners, and this is one of our groups of 3 talking about the psychological aspect of living in space. Additionally, I included a live polling system primarily about the Curiosity rover and the achievements it's found and obtained during its short time on Mars. And this was the same system that James Hemphill used in his evening lecture that one night. And after the teaching portion of the seminar had concluded, the students took a post-test on all they had learned, and using a Google survey, I collected and evaluated the results, and as soon as everyone had finished, I discussed the answers with the class. Here are some examples from the post-test, so you get to learn a little bit about what we talked about. One was, which Mars rovers are currently exploring the planet? The answer was Curiosity and Opportunity, which most of the students did, in fact, get right. The other rover, Spirit, got stuck a while back, even though it was sent up with Opportunity in 2001. and it really hasn't moved since, so it's kind of out of the question. Another question was, which of the following is not a goal of the Mars Exploration Program? Now, the Mars Exploration Program has 4 tenets that it seeks to achieve, and because I gave 5 options, one of them is obviously not a tenet. And based on what they gave me, determining where subsurface water exists on Mars, that was indeed the correct answer, as the other 4 were the tenets of the program. On this slide, I gave questions about some of the different rocket propulsion technologies being considered for the mission to Mars, because there are many different types, and it's really important to select the right one to get the astronauts safely to the surface. The first question asked, which type of rocket propulsion would necessitate an 8-month trip to Mars and would thus not be a viable option for astronauts traveling to the planet? The answer, which was almost unanimous, was chemical propulsion, which is the type of propulsion NASA has used throughout its history with the Space Shuttle program. It's been easiest and most effective, but because we're going such a long distance to Mars, we're going to have to rely on a more innovative propulsion system, because when you're talking about sending astronauts, humans, to a different planet, it's a really long journey, and you have to be able to sustain them in transit, and that requires a lot of food. And because it's about 4 pounds of food per day per astronaut, it's really important that we reduce this as much as possible, because that increases the mass significantly. And when you're talking about space, mass equals money. And when you're sending a single pound of space, a pound of food, rather, into space for about $1 million, it's really important to keep that quantity as low as possible. Another question was, which innovative rocket propulsion technique will likely reduce transit time between Earth and Mars to a mere 39 days? I thought this was the most interesting rocket propulsion technology that I covered, and it was indeed VASIMIR, which is a really cool acronym, and it stands for the Variable Specific Impulse Magnetoplasma Rocket. So that's in consideration for a mission that's being designed right now. On this slide, the final question I gave my students right here was whether or not they would want to take a trip to Mars. Most of them said no, but the results were quite mixed. And this is a really personal question, but could I just see how many of you guys think you would want to go to Mars, even if it is a one-way mission? Yes? If you'd like to go, raise your hand. Okay, well, good for you, you daring people, you. Okay, so after the post-test, I gave my students the opportunity to design their own hypothetical mission scenarios, much like I had done during my time at BAST. I was incredibly impressed at their results as they worked in the groups of 3, because they exhibited very well all that I had taught them. And I can't really show you them right now because they're pretty long, which is really impressive because they, integrated all the knowledge I taught them. But here I have a video of Mrs. Bailey Hennessy, the astronomy teacher who allowed me to teach in her classroom, speaking about the impacts I had on her class and her teaching style, because I use some different teaching techniques that she does not normally utilize, and she's considering adopting them for her own uses. But the video might be sideways, so if it is, you'll get a little neck exercise.
So when Carly came in to present to my students and she taught them a lesson about the Mars mission, it really inspired me to try new and creative different methods of teaching. I loved her little polls that she did, and I really want, like I said, it really inspired me to want to try to do new and creative methods. And using the iPads, again, I would have never thought using them, other than just an app, to use them in a classroom. I thought that the instruction was much more, the kids were more invigorated by using the iPads rather than just the laptops. So I hope that my students were just as inspired as I was by Carly's lesson.
So I believe my seminar was vastly successful. So if you guys would like to pull out your phones right now, you can scan this QR code right here, and that will take you to a website that has the post-test that I gave to students. So if you'd like to take that for yourself, you can, to see how you would have fared. On the website, I've also included the PowerPoint I used to conduct the seminar, as well as the mission scenario that I gave them to design their mission. So if you want to go to the website, you can just snap a picture. Okay. Overall, I could not be happier with the final product.